let the learning begin. So you guys want to start with some 2-6 questions, and then we'll just move into general study guide stuff? 61 is a popular, sure. This is a good one, too. Yeah. Rita, what'd you say there? So 61 says find the limit as x approaches infinity of f of x for all x greater than 1, given that yada, yada, yada. Why do we need this all x greater than 1 piece? Yeah, you want to be well-defined over here. We need the being continuous in the neighborhood. So this is a squeeze theorem, right? Everybody see this?
Yes.
When we have a string of inequalities set up, it's just like standard issue squeeze theorem. So this is the condition for the squeeze theorem. All we have to do is show that the limit as x approaches infinity of the left-hand side is equal to the limit as x approaches infinity of the right-hand side. And after that, we should be, if they're the same, then that's our answer and we're done, right? So if I look at the left-hand side, what do we want to do here? Isabel?
I don't have the answer, but you must be negative.
I don't think so. I don't.
Isn't it on the left side?
Well, it's the left side of the inequality, not the left limit.
Okay.
Ideas here? This should be something that's totally doable with no calculator.
Like multiplied by like 1 over e to the x.
Yeah, that's what I would do.
No, it's such a senior week.
And I'm going to write it as, I don't know.
Oh, e to the next.
Yeah.
Oh, it's the same thing.
Negative, yeah.
Yeah, same thing. Yep. So when I do the limit, I just get 5.
Is it really crazy?
And again, you could put the fraction there and still do the same thing, right? No problem. And how about, yes, Isabel?
So when you're doing the whole thing with like multiplying 1 over like e to the x or like 1 over x, so like a certain exponent, do you usually use the exponent of like the denominator, like the highest?
What you don't want is you don't want the denominator to go to 0.
Yeah.
So in this case, with the denominator as a monomial, I don't really have to worry about that. But if this was like e to the 2x or something up here, then yeah, I would want to use just e to the x because I don't want that denominator to go to 0. Right? Because that's going to get you into something. Oh, what do I do with this now? I have a 0 denominator. That's no good. But because you have the choice of what to pick, just pick the one that makes sure it's like the biggest one that doesn't make the denominator 0. Is that? Okay. How about the other limit?
Multiplied by square root of 1 over x.
Yeah, so we need to have a square root around it because it needs to multiply into another square root, right?
Yes.
But that just becomes 5, and then I have 1 minus 1 over x. Oops. Don't forget our limit. Squeeze it in there. So far, so good? Braden?
For this type of problem, when we have to show the work, can we just since it's e to the x on the numerator on the left denominator, do it so we take the just like kind of.
So if it was a multiple choice problem, for sure, no work necessary, because this is like,
5.
yeah, it's like it's implying that it wants you to do some work here, and just the minimal amount is enough. Like, notice I'm not doing like all the stupid limit laws to like, push the things in and like, like I could do show a lot more work than I need to, but I think that this is sufficient. Yes.
Why did you multiply by square root of 1 over?
Well, I need the square root around it because I need to multiply it inside these radicals, right? And then if I multiply by 1 over x, well, I end up with not like infinity over infinity anymore, right? Because if I direct substituted, it'd basically be like infinity over infinity, right? And that's one of those indeterminates. That's okay? Okay, and now we just need to wrap this up, right? So we've done the hard part. Now we can say, since the limit as x approaches infinity of this is equal to the limit as x approaches infinity of this, that's equal to 5 by the squeeze theorem. The limit as x approaches infinity of f of x is also 5. So you just need that sentence to kind of tie it all back together. Pierce.
Wait, so I know you talked about this before, but why is it important that we pay attention to the questions for all x greater than 1?
Well, it ensures that I'm continuous around, like I have continuity near whatever I'm taking the limit of. So because x has to be greater than 1, I don't end up with like a 0 denominator here, possibility. That's all it's really kind of, it's immaterial, but it's just like covering their bases. It's just the directions covering your bases. Be like, oh, but what if x is, just like, because this inequality doesn't hold, right? If it's, if x is greater than, or if x is equal to 1 or less than 1, because then all of a sudden that right-hand side is like undefined or something, right? Maybe it's infinite. And you can't have like something infinite greater than infinite, like. Okay. Does that feel okay though? Hopefully at least you recognized like squeeze theorem, because you had that string of inequalities, right? That should be big, bright, flashing red light, like attention Walmart shoppers. Squeeze theorem now on sale. Pierce. 49. All right. So it says, find the formula for a function f that satisfies the following. Okay. So this looks a little bit like a problem you would have gotten like in your pre-calculus or algebra 2 class for building out a polynomial, right? So what is this telling us? Right, that's an x-intercept. Great, which means that our polynomial that we're going to use has to contain the factor x minus 2, right? I'm going to have x minus 2. Everybody's okay there? What is this stuff telling me? Well, no, this is like an infinite, right? Because it's going to infinity. And what is an infinite discontinuity telling us? Vertical asymptote, right? So what is this going to look like to have a vertical asymptote? Yeah, I'll divide by an x minus 3, right? Now, we have to be a little bit careful here, right? So if 3 is less than 1, I'm sorry, if we take a number less than 3 and we subtract 3, we're going to have a negative, right? So this is actually, the way we've set this up is heading to negative infinity on this end. So what should I do? Well, because now if I take a number that's a little less than 3, like 2.99999, we're going to get a positive thing in the denominator, which is going to go to positive infinity, right? So I have to be a little bit careful there, but just a little bit. So that part's done, that part's done. And now we need the horizontal asymptote to be going to 0, which means the degree of the numerator has to be greater than, or the degree of the denominator has to be greater than the degree of the numerator, right? So I'll just put a squared on that. That'll take care of that. Or you could notice this. What's that telling me? That's another vertical asymptote, right? What's the factor that's going to be in the denominator for that one? This one was x minus 3 or 3 minus x, right? What's this one got to be? X minus 0, or just x, right? Now, what do you notice here, though, about this asymptote? From both sides, it has to be going down. So it has to be not x, but, well, not even negative x, squared, right? It's got to be pointing the same way, right? So I actually don't need the squared there. I could just put the x squared. And that'll, again, get me the degree. It's not wrong to put the squared on the other thing. It'll, oh, maybe it would be, because we'd lose the opposite ends going.
Wait, why is it pretty good?
Well, we need at 0 it to be going, both going the same direction. That's not going to happen if you had just x there, right?
Oh.
And then we have to just double check here. If we're approaching 0, we'd have negative on top, positive on bottom. That's going to be a negative, right? Regardless of which way it's coming, because this thing is always positive. Whether you're approaching 0 from the left or the right, the x minus 2 and the 3 minus x are still going to give us a negative fraction. So I think that'd do it as our answer. I don't know if they, in the answer, did they FOIL that out, or did they leave that as is? Was this one you could have looked up? I guess I can look it up for you real quick. But this looks about right to me. Yep, that'd be fine. So one possibility, they have in the back of the book, it looks like they did 2 minus x and x minus 3, whatever, tomato, tomato. Give you the same thing. So I just kind of pieced this thing out, what I knew about like polynomials, rational functions, and like recognize that, oh, this is an asymptote, this is an asymptote, this is an asymptote. What does my behavior need to look like to get those asymptotes? Or what does my function need to look like to get those asymptotes? Rita.
How do you account for the first one again? like plus.
This,
Yeah.
that's the HA. So just the degree of the numerator has to be less than the degree of the denominator. And I know it's horizontal asymptote because it's a limit at infinity rather than an infinite limit. Pierce, is this?
Yeah.
Yeah, I feel like I can do it, but like I can't do it myself.
Right. And that's okay. It is. This is a hard question because I'm asking you to go the opposite direction, right? Rather than giving you the thing and asking you to find the asymptotes using the limits, I'm giving you the limits and asking you to come up with the thing, right? Now, if I said, like, write a function that has asymptotes at here, here, and here, you know, like, you could probably have done it, right? The hard part was getting, you know, like, this thing to match up the right way, dealing with this being the same, like, those were tricky, for sure. But, like, all we did was kind of build this out. And this is not something that I would ask you to do on a test because, quite frankly, there's multiple answers here, right? There's lots of ways you could have done this. And I don't think the AP would ask you to do something like this because, again, there's lots of ways you could do it. I think if they were to ask for something, it'd be much more likely that there's like only one or two possible ways of doing it, so it's not a nightmare for the graders. You'd have to include a lot more criteria to narrow this down to getting like a specific answer, which either would make it like, I think, too easy or too hard, or too time consuming maybe, for a single part of a single question. You know, because this would have to live in a free response section. Because if not, it would just be like, well, I'll just check it, you know, like just check it numerically or whatever. Isabel,
Can you do number
25? Does that feel any better, Pierce?
I guess so.
It's one that it's one more like I want you to think about it, right? Like that is really kind of the goal there. So this one here, if we kind of do this naively and we pretend like we can do a substitute, we basically get like infinity minus infinity, right? That's one of those indeterminate forms. I know I can't do anything with, I can't proceed from there. That doesn't tell me anything. So ideas of what I should do,
multiply by conjugate?
yeah, multiplying by the conjugate is exactly what we're going to do. So again, the conjugate, everything stays the same except the plus, or the sign in between the two terms becomes opposite. So when I multiply that out on top, I have 9x squared plus x minus 9x squared. And I got that, right? So now, again, if I still do a substitution, now I have infinity over infinity, right? Still not what I want, but if I do multiply the top and bottom by 1 over x, or if I think about it as the square root of 1 over x squared, I think I'm going to have what I need. So if I do that, I got 1/6. Isabel, is that okay?
Okay, so the part that you multiply by 1 over x, you didn't multiply by 1 over
Well, I used that to go in there, but I just thought about it as regular 1 over x to multiply there.
Okay, so.
Because those are like equivalent, right?
Yeah. So you can multiply the numbers under the square root, like even though they're equivalent, you can still multiply something else, right? It doesn't have to be like 1 over x for everything.
Well, I did use 1 over x for everything. I just thought of 1 over x as square root of 1 over x squared sometimes, and just thought about it as regular 1 over x other times to suit my needs. Right? Because to get it into the radical, I need to think about it with the square root on it. To not get it in the radical, well, I mean, I could still think about it with the radical on there, and then multiply them together, and then reduce, that simplify the radical, and then and it's, I'm just kind of like saving myself the hassle of like writing it down and then reducing, or simplifying and then reducing, rather than just like, I'll just think about it whichever way I kind of need to do the multiplication and cancel in one step. Is that okay?
Yeah.
Are you sure?
Yeah.
Okay, because you didn't seem real happy.
No, I got the right answer, but I was just like confused on like, oh, you're allowed
To think about it the way you want it to.
Yeah.
Yeah, and you can, for sure. Yes. Yeah. Think about it the way that you need to make it work. You don't have to write it all the ways. I'm just kind of like, I wrote that below it so you could kind of, as I'm talking, so everybody could kind of see, oh, you thought about it that way there, and you thought about that way there. 37? Sure. There's.
I understand like the e to the negative 2x.
Great.
I don't understand the cosine of x.
Well, it doesn't really matter because what's the?
0.
Yeah. So 0 times anything is 0.
Yeah.
Right. So yeah, that's. So that part 0 times does not exist, which is just 0.
It doesn't exist?
Well, cosine, the limit as x approaches infinity of cosine x doesn't exist, right?
Because you're less than 1.
It just oscillates between -1 and +1, or doesn't settle down to any specific value. But that doesn't matter because whatever that number is getting multiplied by 0.
Yeah.
Which is fine. It just zeroes out. Now, if this was going to infinity, if you had infinity times 0, I think that is one of the indeterminate forms. But this is fine.
I can just like squeeze 0. If I got the same answer.
Oh.
Does that work?
Yeah, right? So you could have, yeah, sure. Sure. So you could have done like, what, like
Yeah, like that.
start here and then multiply both sides by this.
Yeah.
Yeah. Because this goes to 0, this goes to 0. Yeah, sure. Totally fine. Clever application.
Good job.
Isabel?
Can you also do 14?
14? Sure. Okay, so evaluate and justify each step. I'm going to just kind of like not write the justification. I'll just kind of do it one step at a time. Is that okay?
Yeah, that's fine.
Okay. So multiply the top and bottom by square root 1 over x cubed, right?
Yeah, because that's the
Without zeroing the denominator out, yeah.
and you're getting rid of the square root by multiplying.
No, the square root stays there. You just need the square root to go under it. So the square root stays because you're not multiplying two of the same radicals.
Oh, if it was the same, then it would get.
Right, like if I do square root 2 times square root 3, that's just square root 6, right? The radicals stay. You just need the radical to multiply them underneath, right? To put the 2 and the 3 together underneath. Okay. And then we can like use continuity to just say that like, you know, limit of all these things. You know, strip off the coefficients and tuck them all under the radical. Tuck them in good night. Good night, little equation. And then I'll draw my big radical still living there. Then if I apply my limit laws, or my, you know, limit of a constant is 0, limit of 1 over whatever, 1 over x to the n is 0. And I don't know if that's enough. There's going to be a lot of limit laws that I just kind of like hand waved and did like 10 of them in one place, but is that okay? Yeah. The justify all steps, and then here's one with like 40 steps to justify is just kind of like, nope. I'll do some. I'll do more than usual, but I don't think I'm going to do them all.
Could you tell us like just
No. 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 I think none of the problems I even suggested looking at asked you to justify like with limit laws or whatever. At least I hope they didn't.
I don't think so.
Yeah, I thought I was careful and pick things that's like, okay, don't pick anything that's like the problem itself is dumb, is okay, but the instruction is dumb. You know what I mean? Not that like understanding like what you're using to do this is dumb, but like on a test setting, it's like really tedious and something I'd want to be able to look back and forth on. That just like I don't expect you to have like things memorized by the number. Elena.
So when you went from calc, you kind of expanded and wrote the limit one. Did everything with an accent just become 0?
So you're talking about going from here to here?
Yeah.
Okay, so what I used was the limit as x approaches plus or minus infinity of 1 over x to the r is equal to 0 for r, for rational numbers r.
Oh, it could be like 1 over x.
Oh, I think probably r is non-zero also, right?
Oh, yeah. I just forgot that r could be 1.
Yeah,
That makes sense.
yeah. Or a half, or 3/4, or, you know,
And you said 0.
well, not irrational
Rational
either.
and irrational.
Yeah, you can't have like x to the pi and do this, even though I think that would probably still be okay. But I think I could make it okay. But if you had like x to the 1 over the square root of 2, I don't know what you would do with that. Because the other, I think you could just like separate, think about pi as like 3 plus, and then all the crazy decimal, and you separate out, so you have like 1 over x cubed times 1 over x to the crazy decimal. And the 1 over x cubed part goes to 0, and the 0 times the crazy decimal, choose that up. But if you have just the crazy decimal, you don't know what to do with that. I don't have a good trick in which I would try to get around doing that, but you will not encounter an irrational exponent to put your mind at ease. Rita.
Could you number 45?
Yeah, still from this stuff?
Yeah.
Okay. That's okay. I just wanted to make sure that at some point we're transitioning to the study guide, right? But this is all study guide stuff, I mean, technically, right?
Yeah.
2.6 is 2.6. Okay. 45. So I would start by factoring this thing. Oops. And then that's a difference of 2 squares up there. And I noticed that this would drop out. And if I wanted to, I could like multiply that numerator back out. And I could use that, right? Why do I have the not equal to 1? That's like the removable discontinuity. Exactly right. Yep. So far, so good? Okay. Well, the HA is easy, right? So the limit as x approaches either positive or negative infinity of this is going to equal I guess let's just do them one at a time. Let's just do negative infinity first. It's going to be, bottom will be positive or negative? Negative. The top will be positive. Positive over negative is negative. Okay, what's this one going to be? Top should be, bottom should be. So it's going to positive infinity.
Question about the top one. So it would be negative infinity squared, which is positive.
Mm-hmm.
So how do we know that it's
So here's, don't think about it as infinity. Think about it as a negative, like negative 10,000.
okay.
Negative 10,000 squared minus 10,000 is still positive.
Is it like the powers and like the fastest growing thing?
Kind of, but it's usually you're going to get better into, because infinity minus infinity is indeterminate, right? You want to stay away from trying to use those as your justification. Instead, think of like very small number. And if you just think about it like negative 1,000 or negative 10,000 or even negative 100, you're going to see what's going on. You know what I mean? And that's what I would encourage your like mental process to default to, rather than like plugging infinities in, because oftentimes that'll give you like bad intuition. Oh boy, we're not done with this, just so we're know.
Oh.
Okay, because it asks for vertical and horizontal, right? So I do still have a little bit more to do if we're trying to transition to another question. Of course you do, yes. Everybody's okay with that so far, though. So these are my HAs at, there are none, right? because it's not settling down to a finite value. Now, what would I have to, where am I checking for my vertical? Approaches 5, right? Now, can I plug 5 in? No, right? So I'm going to have to separate this into a left-hand and right-hand limit and think about it that way. So if I pick a number a little less than 5, say 4.999, and I plug that in, the numerator is, the denominator is negative, but it's a really close to 0, right? So this is negative heading to infinity. If I do this one, it's same thing, but it'd be positive over positive. So this stuff tells me I have a vertical asymptote at x equals 5. That's ostensibly what we're doing. It just, if we're in a calculus class, we should be using calculus to show, because this is how we defined a vertical asymptote, right? Was that either the left-hand limit, the right-hand limit, or the limit itself was equal to infinity. What's your definition for saying x equals 5 is the vertical asymptote? How do you know it's not removable, though? Right? Because you could be undefined at the number and, well, okay. But again, like, you know what I'm saying? Like, that's, again, it's not a definition. It's not like a proof.
Right.
It's just like you've claimed it and you're correct, but you just haven't like justified why you're correct. Does that? And my suspicion would be like, if this was a AP question, it'd be like 1 point for x equals 5, 1 point for using the limit to verify that, you know, that it's a, you know, the definition of vertical asymptote. Like it'd be a 2 points attached to that. And just stating it is fantastic. That's probably 1 point. But the second point would have been like using a limit to show that your answer is you're correct, right? Does that make sense? And I don't want to like poo-poo on the, no, you're absolutely right. That's exactly what I did to pick 5 as the thing to check. But the check involved doing the limit, right? Was this Elena? Did you ask about this one?
Oh, no.
No. Who asked about this? Okay. Rita, are you happy with what we did here?
Yeah, it makes more sense.
Okay. And I skipped the graphing device to check because, like, I'm sure you had no problem typing this in and looking at the picture. Okay. Elena, go ahead.
First question, are we gonna, like, should we not do one like 27 where it's just all variables?
27, where it's just all variables.
Yeah. No, it was like, and then I even, if not, then it's not.
So what I would say is I didn't put anything with like not specific, like general coefficients like this on your test, but they certainly will do stuff like that on. Yeah, and I think didn't we have one on the practice here where it had like the answer had a coefficient in it? Was it? Yeah, it was this one right here, right? So like it's a good question. It just, am I going to ask you to do it on Wednesday? No. But it's like should you know how to do it? Yeah. Should we run through it? Okay. Did I answer your question though good enough?
Yes.
Okay, because I felt like that's really what you wanted to know was like for Wednesday, like how much do I have to worry about something like this? And
So I have the general like
Yeah, I mean, I think if you multiply by the conjugate and then you multiply by 1 over x afterwards, I think you're going to be good.
No, it's a good point to multiply by 1 over x.
As soon as you see like you have infinity over infinity.
How do I know that?
Well, like if I substitute in, this is basically going to be like infinity minus infinity, right? If I try to substitute my infinity in, that's indeterminate, right? So that I can't multiply 1 over x over 1 over x because the denominator just can have a 1 over x in it, so it's just going to be 0, which is not helpful to me. So I'd multiply by the conjugate first. So when I do that, and then I'd have ax minus bx up here. I simplified some stuff. So now if I multiply by 1 over x on top or the square root of 1 over x squared on bottom, how I'm going to think about 1 over x. Now, because before I did this, if I plug in, I basically have infinity on top, right? And then I have infinity on the bottom. Infinity over infinity, again, still indeterminate. It's something else I have to do. The only thing I have left to do now, since I've multiplied by the conjugate, I wouldn't do it again, because I'll just end up back where I started. What I want to do then is just multiply by 1 over x to some power. So, is that?
Yes, that actually helps so much.
So I have a minus b on top, and then I'll have like 1 plus 1 over, oops, that's too big. 1 over, I should say a over x plus 1 plus b over x. And that just becomes a minus b, 1 plus 1. So a minus b over 2 or whatever. Is that okay?
Yes.
And I guess these have square roots over them or whatever, but I simplified. Is that pointing out like why I'm the y? Did you get the y part?
Yeah, that helped a lot. Like now I had help numbers, so it's kind of
Okay. And again, like, it's not easy to see that the first time you're doing this. Like, again, like, math teacher, long time. Easy for me. And if I do something too fast, or if I don't give enough detail, or if I do something kind of hand wavy like I did here, and you're like, can you do it like more specifically? Like, ask me, okay? Even if it's not your question you're watching and like, oh boy, you did something, and the person that asked seemed like they got it, but I didn't. Like, can we go back and like, can you get me some more detail on that? Like, I just missed what happened or whatever. That's okay. Anybody. Okay? Okay. Should we study guide, or are we still 2-6ing? I don't want to rush you guys through 2-6. You want to talk more about that? Because that was the first thing I heard someone asking about, but I knew I had some email questions about 2-6 also. Did you guys do 62? Because I looked at a lot of our work, and I don't know that anybody really gave it a good shot.
I didn't even write it down.
Let me check.
I think you're right.
Okay.
Okay. Oh, I didn't.
I asked this because later on this semester, there's going to be like a whole section of questions where you're going to be given stuff like this and then asked to do algebra with it after, or like do calculus with it afterwards.
I don't know if I think about that. But I feel like
I think that's just you.
All right.
no, B, you just do it as it pushes it.
Yeah, that gives you the problem. It gives you the thing. Okay, let's talk about part A then, right? So we have a tank, right? And it contains 5,000 liters of water. And we have like some tap. And in this is coming our salt water, right? So far, so good? Okay. So the this rate of which it's being added is 25 liters per minute. And the salt is 30 grams per liter. Everybody so far so good with just what I've drawn? Okay. So it wants the concentration of the salt. AP chemistry students, how do I do concentration of a solution? There's two measurements. There's molarity and molality. Which one should I be using in this case? I would do molality, where I'm going to do grams per liter.
I don't remember. I'm sorry, Mr. Like I just blocked that out of my head.
But given what we have here, like if we want the concentration of salt, it tells us in grams per liter, right? In the problem. So it should be mass over volume. So I want mass of salt over volume of liquid, right? Okay. What's the problem though? At every instant, those things are changing because we have salt water coming into the tank that's adding salt to the tank and more water to the tank. Okay? So we'll say C of T is going to be the concentration at time T. Everybody agree with that? So let's do the volume first. At time T, we started out with 5,000 liters, and we've added in 25 T liters, right? So if it had been going for 2 minutes, we would have added 50 liters. If it had gone for 10 minutes, we would have added 250 liters, etc. Everybody's okay with that? Okay, how much salt will we have added? Well, it's 30 per liter, and we've added 25 T liters, right? Is that okay? So that's 750 T. Actually, let's just reduce from here, right? So if I factor out a 25 from the denominator, I'd have 200 plus T. And now you're at what they wanted, right? So like no calculus on that part. That was just like algebra, maybe a little bit of chemistry to remember what concentration was. But even if you didn't really remember concentration, like they gave you the units that you needed, so like conceivably that wouldn't have been so bad to work out, but it was a lot of words, right? It was at the end of a problem set, it was probably late, and you're probably just like, yo, I'd give up. What happens when T goes to infinity? Can we do this without writing anything down? Does that make sense? Because eventually the concentration of the salt water you're adding in just becomes the concentration of the whole tank, because the amount of water that you started with becomes so minuscule, it doesn't even really matter, which makes sense, right? If I keep adding, if I have like a vat of water and I keep adding in like Coca-Cola into it, eventually it's just Coca-Cola, right? If I let it go long enough, the water that was in there you won't even know. It's just all Coke. Or if you start off with a cup of water and you dump the ocean in, it's just the ocean, right? It stops being fresh water at all. It's just the same as the ocean was. So look forward to that. That'll be coming. But you'll be much better at calculus by the time that comes, to where the calculus part will be easy and the setup will be the hard part.
Chapters that go on.
There'll be 3, I think. Oh, 4. No, 4. Gotta be 4, right?
I'm thinking they started.
Yeah. Next semester.
Oh, nope, it isn't 3. It's the end of 3. You guys will be so different by the time we get to it by then. You'll be amazed.
Like good different or bad different?
Good different. Okay. Study guide stuff. Or even the MyAP questions, if you want to talk about any of those. Yeah, Rita?
Like when you're doing the
Intermediate value theorem.
yes, intermediate value theorem.
Okay.
It's like I know you have to like prove it's continuous first.
Mhm.
Like how do you like word that? Like I don't know. Can we go for like how like the correct like wording?
Of doing an intermediate value theorem
Yeah.
problem? Sure, of course we can.
Or like maybe the one on the MyAP.
Oh, do the one from the MyAP? Sure, let me
Like
grab.
in the level 1. Like, part
Okay.
B.
Let me find that real quick. That's totally doable.
Thanks.
Yeah. Just waiting for it to load. I guess there's like a million screens to kind of go through.
I want to. What's your base?
Assignments, assigned resources. That was student practice. You're talking level 1. Part A, right?
Yeah, or B.
B. Okay. Okay. All right, so it says the number of books sold in print of a new nonfiction book can be modeled by the function n of t, given below, where t is the number of months since publication, and h is a continuous function for 0 less than or equal to t less than or equal to 10. Selected values of h are given in the table. Yada, yada, yada. Must there be a time t from 0 to 10 where n of t is equal to 1,000? Justify your answer. So to use the intermediate value theorem is I need, a continuous function. Do I have that?
Yes.
So I'm going to just state, like, we are given n of t is continuous. I'm going to recognize that I've read that and I know that it's important.
It's like for this one, it says like in the directions like h is continuous function for that. Like what if it didn't tell you that? Like what would you say?
Oh, yeah. Okay. Because we're talking about h of t and n of t. Those are good, different. Yeah, good point. Thank you, Rita. Okay. H is a continuous function. Okay. So that's n of t is just h of t for 0 to 10, right? So, okay. So I'm going to recognize, I'm going to say h of t, since h of t is, well, let's say since n of t equals h of t for 0 less than t less than 10, and h of t is continuous, and what I'm going to do is I'm going to notice that 1,000, we would have had to cross 1,000 here between 3 and 4, correct?
Right, yeah.
So I would say that and h of 3 is less than 1,000 is less than h of 4. Okay with that? So I would say, so by the intermediate value theorem, h of t, or I should say, there exists a c on the interval from 3 to 4 such that h of t, or I should say h of c, equals 1,000. And since n of t equals h of t on 3 to 4, n of t is equal to 1,000. Maybe I'll say here, and since h of c equals n of c on 3, 4, n of c equals 1,000.
How come it's like h of c, not h of t?
Well, because I found this is the c. There's some c from 3 to 4 where h of c is 1,000, right?
Oh,
And since h of c is going to be the same as n of c on 3, 4, now I have an n of c that, I have some value of n of t that it's that c. So whatever the c was for h of t is going to be the same c for n of t.
and then you use 3 and 4 because it's like the smallest interval possible.
You could have used 0 to 10 still. That would have been fine, because still 1,000 happens between 0 and 2,000, right? Well, 10 would have actually been a problem. Why would have 10 been a problem? Oh, no, 10 would be sorry, 10 is fine.
Okay.
Sorry. I thought that this was a strict, I didn't think it was a or equal to, I thought it was strict. But it's fine, yeah. So you could have done any. You do 0 to 10, you could do 1 to 8, you do 3 to 4, you could do 1 to 8, you could, like anything as long as 1,000 happens in between, you're gonna be okay.
So basically, I just like make clear that like n of t is like equal to h of t.
And why? Yes. And why do you need that? Because you need continuity on that interval, right?
Yeah.
And that happens only for h of t. N of t is probably discontinuous. It probably has a jump discontinuity if we're to try graphing this thing at 10.
But because like it's equal to h of t, it's like continuous.
Yeah, because we know h of t is continuous from 0 to 10. We know n of t has to be continuous from 0 to 10. So anything we can say about h of t on that interval is true.
So you kind of just like disregard the bottom.
Yeah, I didn't need it for this part at all.
It's just like math, it's like confusing. I don't know what's
Yeah.
the bottom one.
Well, this is what I think.
So just like
If all I care about is from 0 to 10, like the stuff that's not 0 to 10, I don't care about that piece of the piecewise function at all. Yes?
Do you just pick 1,000 because it's between 0 and...
no, that's what it's asking.
Oh.
It's like asking if they're
It's asking specifically about, is there a t where n of t is equals 1,000? Is that?
Yeah, that makes it makes sense, like the explanation.
Yeah, and it's, again, like, the fact that you have like the continuity piece that you need is not just for N of t, like made it a little bit more complicated,
Yeah.
the wording, right?
Yeah.
But I think if you recognized in here anywhere that like h of t is continuous and n of t is just equal to h of t over 0 to 10, so n of t is continuous from 0 to 10, you'd be good, right? Like however you kind of stumbled through saying that. But if somehow you're able to be like h of t gives me continuity for n of t for the part that I care about, you know.
Yeah. Yeah.
Was there other AP stuff you want to talk about? Did you want to look at any of the multiple choice stuff? Or
Do you think the multiple choices would be pretty similar to that one that we did?
I would say it's, I mean, I think I don't think it's going to be any, I wouldn't say it's going to be any harder. I mean, it'll include new things that weren't in that first multiple choice, is why I gave you that second multiple choice practice to look at, because, you know, like continuity and intermediate value theorem and stuff like that hadn't, and limits ad infinity hadn't shown up yet from when I gave you that first practice to when I gave you this, you know, this new one includes stuff like that, which is why I gave you another one, right? So like, but the level of questions on that first one I think are very similar. Like you'll see questions very similar to those where you're given like a table and asked to do a limit, or you're given the graph and asked to find the limit, or you're given, you know, stuff like that. Does that?
Yeah.
Okay. Isabel. Of course. I think we have 10 more minutes. Anybody else got something pressing? Okay, so send me an email and make sure you resync that or whatever, and then send me an email. I'm sure it's probably synced by now if you've had it open for a while, but that's probably all that happened. Sure.
Yeah.
Okay.
It was the most recent one. I turned it in Sunday morning.
Okay. There was just like a blank page when I looked, so it was